sublevel blocks that you just colored. We've got the S block, the P block, the D block, the F block, and we tend to refer to them by those block designations a lot. It's useful for a couple reasons. And of course, here's the long view. Once you have seen it, you can't unsee it. It's a wonderful thing. I would love to have this painted full size on one wall of my room, but I don't think we're allowed to do that. But like I said, once you've seen it, you can't unsee it. It makes so much more sense once you see where the F block fits in. So we can talk about those blocks in terms of their characteristics, but to do that, we got to talk about the odd ones in the family. These are the black sheep. What do they say? Every family has a black sheep. If you don't know who it is, it's you. Mine doesn't have one. I don't know who that would be. So anyway, hydrogen and helium are these weird special cases. So if we look here, here's hydrogen, here's helium. What does hydrogen end with? 1s1. Helium, 1s2. So these are the first elements that would have existed in our universe. So after the Big Bang, you would have hydrogen. For some period of time, what they call Planck time, you wouldn't have had any actual atoms of any elements. The first elements to form would have been hydrogen atoms, followed by their collisions generating helium. This is what happens in our sun. We smash hydrogen atoms together. Well, we don't. They smash themselves together with enough force to fuse and form helium. So these are the original elements. And what's interesting is that hydrogen is group 1 because it ends with S1. But when you look at how it behaves like group 17. It behaves like a halogen because it needs to gain one electron, or lose one electron, I'm sorry, to be stable. Well, no, that's group 1 behavior. Anyway, it behaves like group 17. Helium is in the noble gases. It's group 18, but it ends with S2. Everything else below it ends with a P6. It doesn't have any P's. It's only got electrons on the first main energy level. So, you know, hydrogen fits in electron-wise, but not characteristic-wise. Helium fits in characteristic-wise, but not electron-wise. So they're just sort of oddballs, and it comes with the fact that they have very low numbers of electrons. All right. Now, when we talk about the groups, we tend to talk about them in terms of their characteristics. And the S block are highly reactive. These are highly reactive metals. We'll talk a little bit more later about how that reactivity changes within a group. And I've got a fantastic video for you. These, you do not find them on their own in nature. They are so reactive that they tend to form compounds. You can isolate them, but they form compounds almost immediately. If you expose them to air, they form oxides. They react with oxygen immediately. The number of electrons in the highest occupied energy level. What's another name for that? The number of electrons in the highest occupied energy level? Valence. Those are your valence electrons. That's what reacts. That's going to become really important to us. Is the same as the group number. So for group 1, how many valence electrons do they have? 1! For group 2, how many valence electrons do they have? 2! That's nice. That's easy. We call group 1 the alkali metals. We call group 2 the alkali earth metals. I will admit right here and now, I can never keep straight which is alkali and which is alkali earth. And you can look that up, frankly. What you should be able to keep straight and know pretty... By Christmas, you are going to know automatically when I say, what ion does it form? You're going to go, oh, +1. Oh, minus 1. Oh, +2. You're just going to know that. That's going to become second nature to you. So that's the S block. The P block. So this is groups 13 through 18, and I'll flash up our little image here of the P block. We call these and the S block the main group elements. That's how they are referred to, is as the main group elements. Well, that completely obliterated the purpose of that picture. And the number of electrons in the highest occupied energy level, which is also called the what? Valence electron, is equal to the group number minus 10. So you have a periodic table out in front of you? You should always have a periodic table out in front of you. Look at group 13. Okay, so look at group 13 and look at that element that I've highlighted in purple. How would the electron configuration for that element end? It would end with a 2p1, and we would have a 2s2, and we can do this sort of backwards. Now, these things in the highest main occupied energy level, those are the valence electrons. And that's a terrible 2 that I wrote there. Let me fix that. So how many valence electrons does that element have? 3. S2P1. And guess what group it's in? 13. 13 minus 10 is 3. So let's look at this one. And we don't have to, we could do noble gas for this. And this is neon. So that would be neon plus what? 3s1, 3s2, 3p what? 1, 2, 3, 4, 5. How many valence electrons does that have? 7. I heard 7. I heard the sibilant hissing of sevens. 7. Okay, we'll pick it up tomorrow. You will have a brief recall quiz tomorrow on configuration.